Hey, this is Mr. Elmhorst with the math lesson where we're going to look at the distributive property of expressions. So the distributive property is going to simplify expressions, and what it's doing is going to help create an equivalent expression by removing the parentheses from the expression. And we do that by using the factor and multiplying the factor by each term inside the parentheses. Okay, so right down below, there's a simple example. So if we do 4 plus 3, that will give us 7. And then whatever is inside the parentheses is multiplied by the factor outside, which is 2. There's another way to look at it. You can take the term, separate it, and we're going to rewrite it, and take the other term inside the parentheses, take them out of the parentheses, and then multiply each one of the terms by the factor in front of the parentheses. So 2 times 4 is 8, and 2 times 3 is 6. And both of them are going to give us an equivalent result, both resulting in 14. So we can use this idea when we have variables within the parentheses, and we can distribute the factor even with variables and when they are involved. So how are we going to use the distributive property? Well, first we're just going to focus on rewriting the terms and after we separate them and give them their own parentheses. So down below, we have one term and two terms. And let me make sure I circle the sign to the left. And we're just going to take them out and separate those terms. And then we're going to give each one of them their own parentheses. And then we take the factor and we give it to each term after we've taken them out of the parentheses. So we got 3 times x and then 3 times 5. And now this is separate from the parentheses, so we don't need to do anything with that. So now we process the factor. 3 times x is going to give us 3x. And then 3 times 5 is going to give us 15. And then we just rewrite the other term that was not in the parentheses. And now we can combine like terms if we have them, and we do. Here's a positive 15, here's a negative 10 all by itself. So 15 positives, and then 10 of them are canceled with the 10 negatives. So then we have a simplified expression of 3x plus 5. Okay, let's continue to practice with another example. So we have two terms inside this parentheses. So we have 4x, and then we have 1. So we're just going to space them out a little bit, and then give each one of them their own parentheses. And then they also get both their own factor of 2. So we got 2 times 4x, and then 2 times 1. And the subtraction in the middle can stay subtraction in the middle after we rewrite it. So 2 times 4x will give us 8x, and then 2 times 1 will give us 2. And this term is by itself. It doesn't get multiplied. We just move it down and rewrite it within the expression. So now we double check to see if there's like terms, and there are like terms. So 8x plus x. 8x plus x will give us 9x, and then negative 2 or subtract 2 is all by itself. It's just a number by itself. So now we simplify the expression after we distributed the factor. So Continuing with another example, we're not going to look at the factor on the outside just yet. We're going to separate. So we have 4g and 10, space them out a little bit so we can write a factor in there. And I think I'm going to space out a little bit further. There we go. And then there's plus in the middle within that parentheses. Now we look at the factor and we take the factor and put it next to the parentheses after we separated the terms. So this is negative 0.5. So 5 times 4 is 20. And the negative, and then we put the decimal place value back in there. So half, basically negative 0.5 times 4, that's half of 4, which is 2, and we're left with negative 2g, and we have 5 times 10, which is 50, and there's one decimal, so then we put a decimal place value back into after we multiply. And there's no other terms in this expression, so now we can just rewrite it. Negative 2, and there's no decimal, or there's no value after the decimal, so we have negative 2g plus negative 5. We can also write that as adding a negative is the same as subtracting 5. All right, and then this also works even if you have a fraction on the outside. The fraction is a factor of 3/4. So we're going to start with separating the terms. So we have 8y minus 4. Give each one of them their own parentheses and their own factor. 3/4. So now we have distributed the factor to both of the terms inside the parentheses, and we're going to multiply 3/4 times 8. So 3 times 8 is 24, and 24 divided by 4 is 6, and that's y. And then 3 times 4 is 12, and then 12 divided by 4 is 3. So we have our simplified expression after we distributed the factor of 3/4. So all of this is equal to 6y minus 3. I just want to emphasize, as we go back up through here, we have created equivalent expressions. This expression can be simplified to 3x plus 5. This expression with a distributive factor of 2 can be simplified to 9x minus 2. Even though this looks complicated, we have negative 0.5 times this expression. It can be simplified to negative 2g minus 5, and then the last one can be simplified after we use the distributive property. So open your notebooks. We're going to glue this into the next open page after the previous lesson. Don't skip a page and go front to back or side to side.